Distortion is my criteria. What is distortion? Unwanted change in amplitude. Right? Do I want somebody else to change my data? Do I wish for? Never. But it is happening. So then that is a distortion in information. You received a distorted data. Transmitter has transmit the data. Receiver, that means the controller, has received the distorted data. Some factual data, something is corrupt. Right? So that is the reason that in case of PAM, because here I am entertaining change in amplitude. Remember, a change in amplitude itself required more power as compared to change in phase or change in frequency. First two. Okay? Number two, if you look at this mathematics, good thing is that it carries 90% of data. So if I have a error correction and detection mechanism, okay, that is called cryptography. You can reject all this. I don't want. I will limit to this bandwidth. Out of 100 words, I have received 90. Rest 10 I will regenerate. Rest 10 I will fill in the blanks. Understand? Paragraph consists of 100 words. I received 90. There are the 10 filling points. I will fill up it. Things will become more predictable if you can receive 95%. Because then you have to fill only 5. Isn't it? But for that you have to entertain double the bandwidth. This is 1, this is 2. Double the bandwidth. By doubling the bandwidth, you will get additional 5% data. Okay? If you will triple the bandwidth, you will get additional another 2% of data. So it will not even exactly 98%. Somewhere around 96 point something you will get. Okay? Make it one more log. Then you will get more than 98%. Okay? Very highly accurate systems. Okay? Ready to pay the price? Very good device you will get. So what actually manufacturer does? That design the system your receiver in this way that all the times you will get the data. It will accumulate all the frequencies up to 16th harmonic. It will cancel all the odd harmonics. You will add only even harmonics. Okay? And then it will regenerate the data. But bandwidth requirements 4 times. 4 times of this. Okay? You want to reduce the cost? Take the cost one. Reject the rest. That is the idea. The whole idea is. Now recalculate all these things. As I said, in your assignment, assuming that A by 2 is equal to 1 by 2 in place of 1 by 2. So you will see that what kind of changes you are getting. Okay? Now whatever is applicable in case of amplitude, the same is for phase, same is for time, same is for the width, same is for position, same is for the frequency. Okay? Now what will happen if bandwidth requirement is increasing? Distortion was my earlier criteria. Now if I will say that in place of distortion, if bandwidth is my criteria, what it is required, it is here. Bandwidth कितना होगा? What is the bandwidth? How do you know? और तक चलो ठीक है, जेठी हम ले लें. This 4F is known to be classical. Classical means this is A is known, E is known, phi is known, time is known, F is known. In terms of this is there because these data are available. 4F is equal to कितना होगा? कितना होगा? Minimum I have to produce this in case of PAM, है ना? What is it? A. So bandwidth is 1 by this. So the minimum bandwidth is 1 by A. Okay. Now in case of PAM, you are losing more than 10% data, roughly 10% data. So normally what we do, we take 1 more times. Check. In case of the FM. Check. Okay. So that is the comparison difference between the two domains. That if you want to increase the SNR value, better signal to noise ratio, least affected to the unwanted signal, go for, and if at all is allowed in your application, that also depends. So for example, your job is to transmit and distribute the power, okay, just to improve the data quality. Can you afford to play with frequency? Answer is no. Answer is no, because in power and energy systems, those domains will just hit you hard. If you just say that, allow me to vary the frequency, they will say that we are going to make our life hell day and night to just fix the frequency, and you are saying that you allow me to change the frequency. What is your objective? You want constant 50 Hertz, or do you want variable frequency? You want a constant voltage. They will say do whatever you want to do. Don't ask me to change the voltage, don't ask me to change the frequency. Two things will be constant. The whole game is this, isn't it? So there you cannot afford to apply the FM, because FM itself is allowing working on principle of change in frequency. Understand? Okay? So in one case distortion is high, in another case bandwidth requirement is high, but it is providing you better signal to noise ratio. Okay? So if you have a flexibility, go for frequency modulation. If you have a flexibility, go for phase modulation. Okay? The most classical is always amplitude modulation. It doesn't matter digital, doesn't matter analog, doesn't matter pulse. Amplitude, change in amplitude is the foundation, or the basic one you can see. Okay? Rest is in between. Your pulse position, pulse width, those all will fall in between. It has a little better characteristic than PAM, but inferior characteristic as compared to PAM. Understand? So in case of this vibration sensor or accelerometer, we adopted pulse width. We change this A part, active width part, right? We are allowed to change this. Okay? So either you are changing the width or you are changing the position. These are the two different philosophies. Mathematically, more or less both are the same. Okay? In one case, you are fixing the duty cycle. You are changing the position of the cycle. In another case, you are not changing the position of cycle. You are allowing to change the width of the cycle. In place of 1/4, it can be 1/3. It can be 1/2. It can be something. Okay? It can be 3/4, anything. We never go for 3/4, anything. More than 50% is not advisable. Okay? So that is how actually works. Okay? So these many much minimum principle you are going to follow for satisfactorily design or clear? Any question? और आगे जाए, तो नेक्स्ट इज सेल्फ रेगुलेटेड प्रोसेस है, स्टडी करके आओ, है ना, नेक्स्ट टाइम व्हाट इज सेल्फ रेगुलेटेड प्रोसेस, व्हाट इज डेड जोन एंड ऑल दिस थिंग्स वी विल बी फेमिलियर इन द नेक्स्ट क्लास. टुमारो वी हैव अ नेक्स्ट क्लास, राइट? एंड along with that, because many a times you require these amplifiers, PID amplifiers, you are studying in control system, ठीक है ना? So we will see that what is the classical PID controller you design and what is the industrial standard to design a PID controller, which is actually used in industry. ठीक है? So these two things we will discuss in the class. ठीक है? Along with that, if time permits, are we aware with the current standard, voltage standard and power standard? No? No? So please briefly study. Okay? Try to find some time from your busiest schedule. What is voltage standard? What is power standard? What is current standard for C&I applications or instrumentation, industrial instrumentation? Okay? What is it? Okay? something you will also come to know about another two term. One is called live zero standard, one is non-live zero standard. Words are looks very heavy. Once you understand, it's very easy, very easy. Okay, so like class 2, class 3 job. Okay. Industry application is like a coconut, है ना? Looks very tough, very rough from outside, है ना? Okay, and is very soft from inside. ठीक है? With the fresh form of water. Okay, thank you.